Warm greetings to you all. Research Culture Society is a government-registered scientific research organization. Society is working for research community at the national and international level to impart quality and non-profitable services. Our members are scholarly educationists from various universities and institutes of repute. Here the faculties, research scholars and students interested in the area of research are given guidance and support in how their work can contribute to the betterment of our present and future generations. Research Culture Society is conducting conferences, seminars, symposiums, workshops, training and development programs on different themes. Society has organized nearly around 40 conferences, seminars, symposiums successfully at national and international level in association with different educational institutions and published selected research papers as journal special issues and book proceedings. Society is running international level referred, peer-reviewed journals with ISSN and books publication with ISBN. Educational institutions, colleges, universities are being welcomed for Memorandum of Understanding and collaboration to organize events. Society is promoting and sponsoring educational events as well as publishing research work in collaboration. Society also offers membership. The journals associated with Research Culture Society referred, indexed and with high impact factor. Society journals are publishing research papers, articles in all fields and subjects related to sciences, health sciences, engineering, agriculture, pharmacy, commerce, management, social sciences, arts, humanities, education, law and life skills. Research Culture Society also publishes book in both print and online with ISBN. It will also be a co-sponsor for organizing conferences and seminars. Research Culture Society also provides print and online book publications with ISBN. Society invites book publication in all study subjects and categories, thesis converted into book and conference proceedings publication also available. We arrange special lectures on soft skills, communication skills, personality development, behavior improvement, human resource development, career development, general knowledge improvement, environmental issues and improvement etc. in different institutions, colleges, universities and schools. We organize excellence and achievement awards in different categories, RCS awards, SRA awards.
Welcome to all the participants on the third day of short-term training program on MATLAB for scientific research, organized by Research Culture Society. Today also, again, we have Dr. Yogesh Mule sir as a resource person.
Today we are going to see calculus and numerical techniques using MATLAB programming. So in numerical techniques, most of integration as well as derivative has been used in numerical techniques, and with the help of function they define their function like trapezoidal rule or Simpson 1/3 rule. Okay, so before going that, we are going to focus on calculus. So first we'll start with differentiation. Okay, for that we'll see diff command. Diff command is used for differentiation. Okay, so for that, if we need any help regarding this syntax or this command, we can use F1. Okay, just you type F1, you'll get this. Okay, so Diff is nothing but difference and approximate derivative. So this is the syntax for how we can calculate derivative diff x. Okay, then xn, then xn and dimension. Okay, so before going that, okay, I will write here sine of x. Okay, so here giving is only blank box. Why is it? Because we have not shown the value of x. Okay, so here clear all, clear x CLC. Okay, so I will write here sims. Sims is nothing but symbolic variable. Okay, so it is used for symbolic variable, or if we are what we can say dealing with variable. Now in differential or in derivative, we are always dealing with variable, not on a number. So for that purpose, we required sims command. So sims is nothing but symbolic variable. So we have to define here symbolic variable x. So it means it indicating that we are going to use symbolic variable for a function. So I will write here y is equal to differential of sine of x. So this will give the derivative of sine of x. Okay, so while using any differential function, or if you want to use any variable, so you must need to define a variable. Okay, so with the help of sims command, you can define your variable. So sim is nothing but symbolic variable. Okay, so now I want to show some derivative up to sixth order. Okay, so we'll calculate uh, derivative t raised to 6. Okay, so up to sixth order. So for that, I will write here sims t, because I know we are going to use here symbol t. Okay, then differential of t cap 6, t raised to 6, and up to how much we have to differentiate, up to order 6. So I will write here 6. So this will give you 720. Okay, so first derivative you can see. Okay, I'll write here sim t. Then with the help of upper and lower arrow key, we can move the same command. We can use same command. Okay, so if I write here 1, so it will give you first derivative. Okay, if I always, you have to define the variable sims. If you put here 2, it will give second order derivative. Okay, so d square by dt square of t raised to 6 is 30 into t raised to 4. Okay, now we want to differentiate some variable. I will write here sims. We have two variable. Okay, so I will write here y is equal to differential derivative of sine of x into t. So always you put asterisk symbol, okay, whenever you are using any multiplication. So asterisk symbol is compulsory. Okay, what happened here? By default, the function is known for t, so it the function is by default differentiate with x. Now we can define here same command comma t. Okay, it means we are to t. This function is differentiable with respect to t. Okay. So you can differentiate, you can define here value or variable, whichever you want to differentiate. Either you define x, so it will differentiate with x, or if you define t, so it will differentiate with respect to t. So you have to write different differentiable or diff for derivative, then function, then the variable name. Okay, so in order you have to type this command. Then next again we are going to use or define some function. So I will write here what variable I am going to use here. Okay, x. So I will define function exponential of x into cos of x. Okay, semicolon at last is indicating suppress the output. It means it will not show the result for f. Okay, so it will hide the result. And then derivative of f, derivative of f. So this will use un to b formula to execute this derivative. Okay. Then next we want to calculate second derivative of f. F is nothing but function. So calculate second derivative of f is equal to sine of s of t. Okay, with respect to t. So I will write here sims. So you can observe here s and t define. So we need to define two variable here. So I will define sims s cob x s t. Okay, so two variable we have defined. F is equal to sine of s star t. Okay, s asterisk t. So this is the value for f semicolon. Then differential of f with respect to t and second derivative. Okay, so two times we have to differentiate. So I will write here f is nothing but function. We have to differentiate with t, so comma t, and twicely we have to differentiate. So I will write here comma 2. So it will differentiate twicely, okay, with respect to t. And if you want to make some changes, so you can differentiate with respect to yes also. So I will write here instead of t, just write s. So it will differentiate with respect to t. Okay. So next is we can see x raised to n formula. So for that I need to enter here two variable x and f is equal to x raised to n. This is our function and differentiate f. Okay, so this will give derivative of x raised to n is n into x raised to n minus 1. Okay, so for the value in symbolic number, so you can use c is equal to sim, okay, in bracket single quoted 5, okay, and difference derivative of c. Okay, so derivative of any constant function is 0. If you observe here, I have written only sim. So sim is nothing but symbolic number, and sims, syms, sims is nothing but symbolic variable. So these are the difference between symbolic variable. Sims is used for symbolic variable and sim is used for symbolic number. Okay, then we can see the symbolic matrix as its input. Okay, so I will write here sims ax, and capital A is equal to, now I'm going to type the matrix of order 2 by 2. So I will write here a star x, ax, comma or space you can use for a row. So a star x, it means in first row we are defining two elements, cos ax and sin ax, semicolon for next column, okay, next row. So minus sine of a star asterisk x minus sine ax, comma or space you can use for next element within the same row. So cos of ax. So this will give us the result. Okay, so this is our matrix A. You can differentiate A, so you'll get derivative of A. Okay, so by default it will differentiate with respect to x. So cos of ax, so you will get minus a sin of ax. Then derivative of sin ax is nothing but into cos of ax, and so on. So with the help of matrix, you can also use the symbolic matrix and differentiate. Then next, we are going to find the value for Jacobian matrix. So we know how to calculate Jacobian matrix. Okay, for order 3 by 3. So I will write here Jacobian matrix. Jacobian matrix. Okay, so I'll write J is equal to dou of x comma y comma z divided by dou of r comma lambda comma phi. Okay, so in Jacobian matrix we'll get the result like this: derivative of x with respect to r, derivative of x with respect to lambda, partial derivative of x with respect to phi. Okay, in the same manner you will get derivative of y with respect to r, partial derivative of y with respect to lambda, partial derivative of y with respect to phi. Okay, and final same for z, derivative of z with respect to r, with respect to r, then sorry z with respect to lambda dou z by dou phi. So this is our Jacobian matrix. Okay, so we are going to use here our formula for to calculate Jacobian matrix. So we'll see what we are going to use here. So instead of r, okay, we are using only r. Then for lambda I will use l, and for phi I'm going to use f. Okay, so first we have to define value for r, l, f. So I will clear the screen. Then I'll put here sims, symbolic variable. So I'm going to define r, l, f as a symbolic variable we are going to use in our program. So x is equal to, okay, so x is a function having r into cos of l into cos of f. Okay, I will suppress the output. It means we will not show the result of x. Okay, I don't want to see the result. Okay, the next function y, r into cos of l, cos of l into sine of f. Okay, again I will suppress the output with the help of semicolon, and at last z is equal to r into sine of l. Okay, again I will suppress the result. Okay, wait a minute, I am just mute my hello. Okay, so in Jacobian function we have defined function x, function y, function z. Okay, as given partial derivative of x comma y comma z. So we are having three functions. Okay, now we have to differentiate with respect to r, l, f. Okay, so I'll write here j for Jacobian. So with the help of Jacobian command, okay, so in Jacobian we have to define x semicolon y semicolon z. Okay, comma the next with r comma l comma f. Okay, then press semicolon, hit enter. So it will first in a first row first column. Okay, first row first column, it will differentiate with respect to r. You can see here it will differentiate with respect to r. Value of x differentiate with respect to r. The next first row second column, it will differentiate with respect to l. So derivative of cos l minus sin l. Okay, and at last it will differentiate with respect to x. So derivative of x with respect to r, derivative of x with respect to l, derivative of x with respect to f. So in the same way, second row, the y function it differentiate by r, y function differentiate with respect to l, y function differentiate with respect to f, and at last z differentiate with respect to R, second differentiate with respect to L, and at last differentiate with respect to F. But in a Z function, F is not here, so it will show 0, derivative of constant 0. So this will give us the Jacobian result. Okay. Then we'll see how the mathematical operator we can use in a MATLAB. Okay. So to define df by dx in MATLAB, we can use command differential or derivative of f. Okay. Or if you want to differentiate with respect to x, you can define derivative of f with respect to x. Okay. So here you can show the variable name with you want to differentiate. Okay. Then next, if you want to differentiate twicely or second order derivative of f, so we'll write here derivative or differential of f. F is function. Then we have to differentiate with respect to y, so here you put y, and how much time you have to differentiate, twicely you have to differentiate, so I will write here 2. Okay, f is a function, with respect to y we have to differentiate, and how many times we have to differentiate, twicely we have to differentiate. Okay, and for Jacobian dou of x comma y, okay, this is second order Jacobian, so RT. So you can use Jacobian. This is the command for to find Jacobian. Okay, so I'll write here Jacobian of x comma y, or x semicolon y, not or x semicolon y, comma, okay, I will write here, write down r comma t. Okay, close the bracket. So with the help of this command you can find the derivative of any function. Okay, next we are going to see the integration. Next we want to see integration. So for that we are going to use int of f, or we are going to use int f comma with respect to x or with respect to y. So we can define with which variable we want to differentiate. Okay, so we have to define that variable. So first we'll find integration of x raised to n. Okay, so you must remember, whenever we are dealing with variable, we must enter sims command. Okay, sims commands is nothing but symbolic variable. So now we want to integrate the function x raised to n. So we must secure the variable x and n with the help of sims command. Sims command is nothing but symbolic variable. So I will write here integration of x raised to n, and just hit the enter button. Okay, so piecewise, now you will see the result piecewise. If n is equal to -1, if n is equal to -1, you will get result log of x. Obviously, if integration of x raised to n dx. Okay, so if n is equal to -1, it means x raised to -1 dx nothing but integration of 1 by x dx. So integration of 1 by dx is nothing but log of x. Okay, the same thing is given here. If n is equal to -1, you will get log of x. If n is not equal to -1, okay, so this tilde symbol is nothing but not in MATLAB. Okay, so this tilde symbol is nothing but not. So n, if n is not equal to -1, then this will give the result x raised to n plus 1 upon n plus 1. So we know the basic formula for integration of x raised to n dx is nothing but x raised to n plus 1 upon n plus 1. Okay, so many times when you are dealing with integration, you will get the same result. Okay, so we must understand the definition of integration. Then we'll see next example. Before that, I will clear this. Now I want to calculate integration of, I will write here, integration of sine of 2x with respect to x, okay, with limits 0 to pi by 2. Okay, so this will give result, our answer must be 1. So for that, I'll write here int of sine of 2 into x. So whenever you are dealing with multiplication, you must use asterisk symbol. Okay, then limits 0 comma pi by 2. Okay, so simply just type pi is nothing but pi. Okay, so we have defined here function is sine 2x and limit 0 comma pi by 2. Just hit the enter button, you will get 1. Okay, so here we have not defined that we are differentiating with respect to x. So because in this function only we are using only one function, so instead of this command you can also use when more than two functions are available in your function. So I will write here x. X is nothing but we are integrating this function with respect to x. Okay, so first is function, second is we are integrating with with variable x, then limit 0 comma pi by 2. Okay, sorry, 0 comma pi by 2. Okay, 0 is lower limit and pi by 2 is upper limit, so you will get same result. Okay, so next again I want to integrate cos of at plus b. Okay, and same we are differentiating with respect to t. So for that I need sims. Okay, we'll define how much variable we need a, t, b. Okay, for our security purpose we'll define 3 variables. Okay, so I will write here g is a function which is having function cos A into T plus B. Okay, I don't want to see the result of G, so I will suppress, then use command G comma T. Okay, so here we don't have any limits, so just hit enter. Okay, so integration of cos is nothing but sine of AT plus B divided by A. So this will give the integration of G function. Okay, so here we'll see in integration. Okay, in integration, if we want to define integral AB f of x dx, so we will use int command. Int is nothing but integer, then define f as a function and lower limit comma upper limit. Okay, then again integration from a to b f of y dy. Okay, so I will write here integration of f. Okay, so we are integrating with respect to y and limits a comma b. So with the help of this syntax, you can find out the integration of any functions. Okay, so again, if we want to see one more integration, integration of 1 upon a square plus x square. Okay, this is a square plus x square. We will find integration of this function. So I will write here sims command for symbolic variable ax clear. Clear, here we are use clear for to clear all value of a and x. Okay, so I will define here function 1 upon a square plus x square. Okay, I don't want to see the result. I will suppress with the help of semicolon. Suppress the result with the help of semicolon. So capital F is equal to integration of f. So we are define function. So we have to differentiate with respect to minus x only, and then put just close close bracket. So here we don't have any limits, so I will just hit enter. A tan x upon a. So a tan means arc tan. It means tan inverse of x by a divided by a, means the formula for integration of 1 upon a square plus x square is nothing but 1 by a into tan inverse x by a. So this will give us the integration of tan inverse. Okay, we'll clear the screen. Now we'll see the product of series. Okay, we'll see the product of series. For that we are going to use syntax sim product. Okay, and expression. So here we are going to define sims k. Sims k means symbolic variable having variable k. Sim product sim product k, and now we want to product from 1 to 5. So up to 5 it will gives us the symbolic product. It means we are getting the factorial product of series is nothing but we are getting factorial. So yesterday yes, yesterday we have seen the how to calculate the factorial of any number with the help of for loop. Okay, so here another command for factorial, that is sim product. Okay, so this will give symbolic product. So we can define only a symbol. So what value we will get, we'll check sim product. If we define only k, so we'll get factorial of k. Okay, so here if we define only k, it means we are calculating the factorial for variable. So obviously you will get factorial of k. So with the help of sims command, we can find symbolic values, symbolic calculation. Next we are going to see sum of series. Sum of series. For that we are going to use syntax. So syntax for symbolic sum of series. So sim sum. Okay, and just write expression. Okay, so I will write sims k and sim sum. So I want k as a variable, and from 1 to 10 we are calculating sum of series. So if you add from 1 to 10, you will get 55 as a result. So again, yesterday we have seen how to calculate the sum of series with the help of for loop. Okay, so for that, okay, we'll see the example for that. Okay, we'll write here x is equal to 0. Okay, so for I is equal to 1 to 10, because up to 1 to 10 we want addition x is equal to x plus I. Okay, then and just print x, so you will get value of 1 to 10 sum of series. So we have defined x is equal to 0, then we have mentioned for the loop will move from 1 to 10. Okay, then x is equal to x plus I. So previously we had defined value for x is 0. So now value of y, initial value of I is 1. So x is 0, 0, 0 plus 1. So 0 plus 1 is 1. 1 will be stored here. Then end. So value of I is 1. So it will increase by 1. So now I become 2. Okay. Now value of x is 1. So 1 plus 2, 1 plus 2 is 3. Okay. So it will save value of x is 3. Then add I, now value of I is 2. So it will again increase by 1. So it will 3. So similar, in this way it will carry on. So I will write here, okay, for clarification, x is equal to 0. With the help of arrow button, arrow key, I am using this. Okay, or I will write here x, and so you can see here, you can see whenever loop is executing, it will add at the first loop you will get 1, then second loop 1 plus 2 is 3, then third loop 3 plus 3 6, then fourth loop 4 plus 6 10, in fifth loop 10 plus 5, 15, and so on. So in that way you will get the result as a sum of series. So for sum of series, which command we are going to use? So sim sum. Okay, sim sum expression. Okay, so with the help of this command you will get the result. Next we'll find the Taylor series expansion. So we have seen Taylor series in numerical analysis as well as complex analysis. So Taylor series expansion. Okay, so for this syntax we are going to use simply as a Taylor and expression. Okay, so for that again we need variable. So for that we have to define symbolic variable sims s x symbolic variable, then just put Taylor. Okay, now I would like to see exponential of x in a Taylor series. So we'll start from this. So 1 plus x plus x square by 2 plus x cubed by 3 factorial. Here 2 is nothing but 2 factorial, x raised to 4 by 4 factorial, x raised to 5 by 5 factorial. So this is our e raised to x. So Taylor series, we know the Taylor series. In Taylor series, e raised to x is nothing but 1 plus x, okay, plus x square by 2 factorial. This is nothing but 1 factorial, x cubed by 3 factorial, okay, plus x raised to 4 by 4 factorial, and so on. So you will get the result. Now it will show only up to 5th level. So if we want above this, we can use the command. I'll write here. Again, we need to define sims x, Taylor exponential of x, comma, order. Up to which order? So in order, so first letter always remember capital. We are using capital letter for order, and comma up to 8 or 9 I want to see. So okay, with including 1, okay, so this is 1 2 3 4, okay, for power 3 we are counting 4 because this include 1. So up to 9th order it will show x raised to 8 and 8 factorial. Okay, so you can see the Taylor expansion with order, or by default it will show up to 5th order. So this is our exponential e raised to x Taylor series expansion. Again we'll see some Taylor series expansion of sine of x. Okay, so x raised to 5 upon 5 factorial minus x cubed by 3 factorial plus x. So this is our sine x Taylor series. Again we'll see its order up to 5 or 6 7 8. So I will write here order 9 up to 9. So this will give us okay. So here we can only able to see here. Okay, so for that 9 order it means it will count from this all number, okay, like this is 1, 2, 3 up to 8, okay, up to 8. This will, you can see here, exponential of x, and up to ninth order it will show x raised to 8, but in sin x it will take only x and odd number, x cube, then x raised to 5, then x raised to 7, okay. So if you can see here, x, x cube, x raised to 5, x 7. So sign of x is plus, minus, plus, minus. Similarly, for cos x also we can use Taylor series for cos of x order 9, okay. So it will show up to 8, okay. So here 1 is counting, x is not counted, then x square, even values are counted here, x square, x raised to 4, x raised to 6, x raised to 8, plus, minus, plus, minus, okay. So in this way we are getting Taylor series expansion. Next we'll see transformation. Okay, we'll see transformation or integral transform. So in integral transform we are having Z transform, Laplace transform, Fourier transform, Hankel transform. So in this tutorial we are going to see the Laplace transform, okay. So how we can use Laplace transform? For Laplace transform, we know the Laplace transform of f of t is equal to integral over 0 to infinity e raised to minus st f of t, the function, given function with respect to t, and all this value will be changed into f of s. Laplace transform means we are transforming variable t in the form of s. Time domain will change into frequency domain with the help of this integral value. So we can use integral, okay. So e raised to minus st is kernel, this is our kernel, okay. If you are belong to mathematics, you know the kernel. F of t is a function, given function, and dt, okay. So with the help of integration you just define separately this function, okay. So I can write here int, okay, e raised to minus st into f, okay. F is nothing but function, comma, with respect to t we have to integrate, so I will write here t. Then we can use lower limit and upper limit. Upper limit is infinity, so for infinity we'll use inf as a infinity. So you can use int function also, okay. So with the help of int you can calculate integral value. So we know, we'll see some Laplace transform. Laplace transform of e raised to at is 1 upon s minus a, okay. Laplace transform of sin at, you will get a upon a square plus a square, okay. Laplace transform of cos at, you will get s upon a square plus a square. Similarly, inverse Laplace transform of 1 upon s minus a, you will get e raised to at, and vice versa. Inverse Laplace transform of a square a upon a square plus a square sin at. Inverse Laplace transform of s upon a square plus a square, you will get cos at. So we'll see how we can find out the Laplace transform for this. So I will start with the help of integration. So I will use integration of, we'll see sin at. Okay, sin of, before going that we need to define symbolic variable a comma t. Okay, int integrate sin of a star t. A star t, we have to differentiate with respect to t. We just miss exponential of minus s into t. Now it will show an error because we have not defined s variable. Okay, so it will obviously define error 0 comma infinity. So it will, let's see what answer we'll get. You can see at the bottom it is busy. Okay, so superb, it has shown the value a upon a square plus s square. Okay, you can see here Laplace transform of sin at is nothing but of this plus limit of minus exponential t minus ts into this bracket up to this bracket. Okay, divided by a square plus s square, and limit is infinite, means infinity. So exponential, if we substitute limit t is equal to infinity, then here value of e raised to minus infinity is 0. Okay, value of e raised to minus infinity is 0. It means the limit you will get 0. So whole answer is a upon a square plus a square. So we can use the command Laplace of sin at. So before that we have to show sims command, and we have to just secure our variable a and t. We'll use command Laplace sin of a star t. Okay, so this will give the same result. So this will give directly result a upon a square plus a square. So limit of that function will be 0 when limit t tends to infinity. Okay, the t tends to infinity is given. You can see at last t is equal to infinity. So this will become 0. So with the help of this command, Laplace command, you can find out Laplace of any function, and I Laplace, it means inverse Laplace transform of a. Okay, before going that we have to define the variable a. Now answer is in the form of a and s, so we want to find inverse, so we must know the variable name. So I will use as. Okay, so I will write here I Laplace of a divided by into bracket a square plus s square. Okay, bracket close, just hit the enter. So you will get inverse Laplace transform of a upon a square plus a square is nothing but sin at. So you'll get here, you can see Laplace transform of sin a t is a upon a square plus a square. Okay, and inverse Laplace transform of a square plus a square is nothing but sin a t. So with the help of integration and derivative, okay, here we have used integration to calculate the Laplace transform. So with the help of integral and derivative, you can solve any transformation, any numerical value, any numerical method program. Okay, so you just make a program how we can calculate in the form of coding. Okay, again we'll see some inverse Laplace transform. Okay, so for that I'll use sim a t, because sims a s. When we are dealing with inverse Laplace transform, so we will have any constant plus s variable, and when we are dealing with any transform, so that value will be any constant or in a time domain. So I will write here I Laplace inverse Laplace transform of 1 upon s square. Okay, s square plus 9. So this will give, okay, some spelling mistake, a is missing. Okay, so this will give sin 3t by 3. Okay, so again this is Laplace transform for inverse Laplace transform for 1 upon s square plus 9. 9 is nothing but 3 square. So we know the formula for sin a t, a upon a square plus a square. So constant is missing. Okay, here constant term is missing. So 9 is nothing but 3 square. So here value must be 3. So that's why here is in division 3. Okay, now with the help of Laplace transform, we can find out any, what we can say, second order derivative, and we'll find out the solution for second order differential equation. Okay, so we'll write here differential equation. Okay, d square y by dt square, okay, plus 7 dy by dt, okay, plus 10y is equal to 20, having initial condition y at 0 is equal to 5, okay, and dy by dt at 0 is equal to 3, or you can write y dash 0 is equal to 3, or in MATLAB term you can write dy at 0 is equal to 3. Okay, so we'll find the value for or solution for this differential equation with the help of Laplace transform. Okay, so I will write here variable name. So how much variable will required? Now you can see y will require, t we will require. Okay, so I will write here y t. Okay, then next I will require some s, because if we find out Laplace transform of t, it will show result in the form of s. So I will require s, and for storing purpose I will secure two variable capital Y and capital S for storing variable. Okay, so we'll just make secure our variable. So I will write here sims y comma t, sorry, space s, y t s, capital Y space F. Okay. So Laplace of differential. Now you can see here again we are using formula for derivative. So y of t is a function and t comma t. So it means d square y by dt square double t is nothing but t square. Okay, plus 7 into differential y at t only single derivative plus 10 into y at t, okay, is equal to 20 single quote, and all value will convert into s. Okay, so we'll see. So this will use the Laplace transform for this. Now you can see here Laplace transform of function t. T is time domain and has converted into s. Now in this equation we have to substitute this value. Okay, we have to substitute this value. Now we don't have defined any variable for this, so I will use this answer. Okay, so I will write here F, capital F, to store variables or any value. Substitute. Okay, now I want to substitute what we have to substitute and where we have to substitute. Now in answer we have to substitute this value. Okay, we are going to replace this variable. So where we have to replace? In answer variable. And what we have to replace? So we'll write in a curly bracket single comma Laplace. What is the value? Laplace y of t. Same we have to type whatever given is here. Laplace of y at t comma s. Okay, this value we have to replace. Okay, so I will write here close with single quote and curly bracket. Okay, what we have to replace? I'll replace here with capital Y. Okay, so what this command is indicating, now we are going to substitute value where we want to substitute in answer variable. Okay, what we have to substitute? Laplace y of t comma s, and instead of this variable we are going to use only capital Y. Okay, so you can see 7s. Okay, 7s. Now you can see here 7s into this value. So capital Y is replaced here. Now you can see here s square into Laplace. So you just see s square into Laplace. So wherever you can see capital Y, so it is Laplace of y of t. So you can see here 10 into Laplace of y of t comma s. Okay, so just we have replaced the value for this. Okay, so this is our result. Now we know the value of y0 and derivative of y0. Okay, so this is our function and these are the initial condition. So y at 0 we are going to substitute value 5, and for this derivative of y at 0 is equal to 3. So again we need to use this command. So I'll write here capital F is equal to substitute. Now where we are going to substitute? Now we are going to substitute at F. Now here F is having this value. Now what we have to substitute? Just write in a curly bracket in a single quote. Now I want to substitute at y at 0 comma second in curly bracket capital D is indicating first derivative. Now whatever is written is here, whatever given is here, we have to type as it is. Okay, so second we have to replace value instead of this. So what value we have to replace? So y at 0 we are going to replace 5 comma derivative of y at 0 is equal to 3. Okay, so these two value we are going to replace instead of y at 0 and dy at 0. Okay, just hit enter button. So this will give the value of f. Now we will solve the value of y. Okay, so here is y. Okay, again capital Y, again capital Y. It means it will automatically, with the help of solve command, y will take common. Okay, and all other things will move to right hand side. Okay, so I will write here y is equal to solve. What we have to solve? Capital F, and in capital F we have to solve the variable y. Okay, this will separate the value of y. Okay, now you can see 20s is given. Okay, minus 30 will move right hand side, so minus will become plus. Okay, then minus 5s will move on right hand side, so minus will become 5s. And if you take common y, so you get s square. Here is s square, 7s and 10. Okay, so we'll just take y common. So we solve the value of y. Okay, then we'll calculate inverse Laplace transform of small y. The value is in the form of y. So we'll write here inverse Laplace transform of y. So this will give the value 6 into e raised to minus 2t minus 3 into e raised to minus 5t plus 2. So this is our required solution. So at last we'll plot the command easy plot. Okay, this will give easy plot. Okay, so for that, if you type any command, you just click entry, so you will get the whole function. Okay, so I'll write easy plot. Okay, where is the value in the form of y, 0 to 10. You can give any value, so I'll give the limit 0 to 10. Okay, so this will give the plot for this expression. Okay, so these are the result for this. So with the help of Laplace and inverse Laplace transform, we have find the solution. Okay, so you can directly find with the help of dsolve. So to solve derivative, we can use dsolve. So d2y means double derivative of y, then 7 into dy. Okay, plus 10y, 10 into y. This is another method to calculate initial value problem, and we'll substitute initial value y at 0 is equal to 5. Okay, this is our first value, initial value condition, and dy derivative of y at 0 is equal to 3. Okay, and just hit the enter. Now you can see you will get the same result with the help of Laplace and inverse Laplace transform, and with the help of dsolve command we are getting same result. Okay, now at last we'll see the trapezoidal rule, how we can use integration to solve trapezoidal rule. So we'll solve sine of x with respect to x, okay, with limits 0 to pi, and it will show the result 2. Okay, it will show the result 2. This will give answer 2. Okay, so I will write here x. Okay, x as a limit. So 0 to, I will take here pi by 100 part of pi and pi. Okay, so I will suppress the result with the help of semicolon. Okay, so 0 to pi, this is start point and end point, and we just make 100 parts. Okay, and y is the function. What is the function? Sine of x is the function, 100 value. Okay, so you will get 100 values. Then again hit enter. What happened? Okay, so y is sin x. Then next I'll use z is equal to trapezoidal. TRAPZ is indicating trapezoidal x comma y. Okay, just hit the enter. You'll get the answer. 1.9998 is nothing but 2. Okay, so we can use another technique to solve this trapezoidal z with the help of integration. So I will use function int integral. Okay, integral of x comma, we have to integrate with respect to x, and initial value is 0, means lower limit 0 and upper limit pi. Okay, and just hit enter. What happened? Okay, we have not show the symbol Cmax. Before, whenever we are going to use any differential command or integral command, you must use the sims command, symbolic variable. Then we'll use the same command. Okay, so this will give us the value 2. So you can see with the help of integration you can solve trapezoidal rule. Okay, in the same way you can find any numerical method problem or any ordinary differential equation problem. Okay, so with the help of coding you can make a function. Now trapezoidal is a function. We are using ready-made function, and they have using same commands. Same, they have used coding, and they have given ready-made commands. Okay, so with the help of integration and differential command, you can solve any numerical methods or numerical problem. Hope you will get more solution from this. Okay, so we'll stop here. Thank you. If you have any question, you can ask me.
Thank you, Yogesh sir, for having such a good informative session today also. So now we are opening for the participants, those who have any queries or questions.